Thank you all for attending this session. We will be starting this session within a couple of minutes. Let's wait a few minutes for others to join, then we can start the session. Okay, I hope we can start the session. So myself, Vishnu, I am working as a .NET programmer here in Thiruvananthapuram. So this is my channel, and every week I will be presenting some technological topics. So last week we were discussing about some of the similarities and differences between the Amazon Web Services and Microsoft Azure. And today in this session, I will be guiding you through one of the two major category of service, like the identity management and the compute services in Amazon Web Services. So this identity management is used for deciding who will be accessing the cloud resources, and the compute is a kind of a processing power that you can borrow from the cloud services, and those are the two things which we are going to discuss. So there are a couple of services that are provided by both the platform Amazon Web Services, and we will be discussing all those things. So I will be sharing my screen, and I will explain all these things in a bit more detail. So we will start with understanding some of the different services, an overview of about the cloud computing is just an overview, and then we go deep into some of the different services, an overview of different category of services in Amazon Web Services. Then we specifically look into the identity management and the compute, that is the processing thing. Even in compute there are a lot of sub services, like the VM is there, then the container service is there, then the kind of AWS Lambda is there, that is used for serverless applications, and such kind of lot of things which we are going to discuss in this today's session. So there will be a break in between, around 10 minutes break in between, and we will continue the session. So the session will be recorded, and it will be available on my channel, so feel free to watch it at any time according to your convenience. If you feel any doubts at any point of time, you can ask that in the group chat. So if there are a lot of questions, and then I may be including that as a text file. The answers to that questions may be added as a text file, and I will be shared that below this video, so you can refer that later. So with that, let's start. Let's share my screen, and then we can look into some of the things. So once again, thank you all for attending this session, and please feel free to share with others as well. Okay, so let's look into the Amazon console now. So I will be explain to you about how you will start developing using the Amazon Web Services. So before that, let's a quick overview about what is cloud computing. So cloud computing is a way by which it's kind of an on-demand accessing resources from some particular cloud vendors. So there are a lot of cloud vendors out there, and the popular currently in market are like the Amazon Web Services, then the Microsoft Azure, as well as the Google Cloud. So Google Cloud is also relatively new into the field, but they are also picking up, and Amazon is the one which started earlier. They started around in 2006 with the EC2 service, and then they later added the S3, which is a storage service for Amazon, And eventually they added a lot of other features into their pipelines. And today when I discussing this, there are nearly around 176 total services in Amazon Web Services, each offering a different set of services. So a lot of services are there. So if you want to understand about those services, you can click this menu and that will be categorized in different areas. So there are a lot of service. So there will be services for compute, there will be services for container based application. For storage purpose, there will be another service, and like that different set of services are there, and we will be diving all that in this session. So I explain you about how to get started with this cloud. So the many of you already know that the traditional form of development was like an on-premise form of development where you hire the infrastructure and machines needed in advance for your organization or whatever development purpose you want. So you have to spend a lot of upfront cost for that thing, even though you don't know the extent of scale you want for your application. So the cloud solves that problem. So in cloud you have the provision for on-demand scale. So if you want more processing power or more VM or more instances, you can instantly scale that up and down. So in case if you don't want that resources, you can scale that down. So this means that you can start with a kind of a minor level, and then you can move that to a higher level with more instances as your application evolves. So that are some of the flexibilities that are provided by the cloud computing platform. If you are new to cloud computing, I suggest you to refer some of the other sessions as well, so that you will get an idea of what cloud computing is all about. So out of cloud computing, there are different vendors out there, and this Amazon Web Services is one such vendor. So how to get started with this is you have to create an account. Amazon provides a free account by which you can sign up. You have to provide all the required informations and then you can sign up. So once you sign up, you will get a portal like this, and that is the thing which you are viewing now. So they are offering a list of services, and now you have an application you want to develop, and your application needs some particular service, and you will be hiring that from the cloud provider, and you will be paying for the cloud provider whatever service you are renting from them, and that is the concept of cloud computing. So let's understand a bit of some of the services in detail. We can go through the agenda will be like this. We will be looking at some of the services here, and then we dive particularly into a particular category of services called this identity service, which is used for authenticating into a particular resource in Azure. You decide who want to access the a particular resource or service in Azure and who don't want. So all that you are defining in the IAM or the Identity Access Manager. So we will be diving into that thing a bit later, and then look into some of the other things as well, like the Key Management Service, Cloud Hsm and Directory Service and all those things. Just an overview, and then we look into some of the other stuffs like the compute. So in case if you want to have some processing power in cloud, what are the type of services that are available in cloud for that purpose. So we will be looking into that as well. So this is just an overview. I'm going to start. So in case if you want to access any services, you can access that straight away from here, or there is a search also provided at the top. So in case if you want to access some relational database management system, you can type that straight away. For example, if I am interested in purchasing a SQL service from the Amazon, so I can type that, and it will automatically highlight the associated category, that is the relational database service by which I can create a particular SQL service. So the concept is a bit different in Amazon versus the Microsoft Azure. In Azure, there will be a separate service for Microsoft SQL Server, whereas in the Amazon, it will be kind of a multi-model, like you have to select the relational database service, and from here you can select what type of database you want. You can select and create an Oracle database once you select this, or you can create a Postgres server or SQL server, MySQL, or whatever as you prefer. So that's just a quick overview. So let's start. So first we are going to discuss about just let's understand a bit about the different services. First we can look into the some of the storage services that are provided by the Amazon Web Services. So S3 is the one which they came up initially. So this is a kind of a flat structure storage by which you can store any type of file you want. Then the elastic file storage is there. Then the FSX is there. This is kind of a Windows file share system by which you can store the associated thing. Then S3 Glacier is a bit high for high premium type of S3 storage. Then there is storage gateway. Then there is AWS backup, which provides the services for backing up the data and such kind of things. Then there is a database section. So database offers different types of database, like the relational database. If you want the SQL server or MySQL or Oracle or whatever form of relational databases that are supported by the Amazon Web Services, you can create a relational database service from there. Then the DynamoDB, which is one of the popular service that is offered by Amazon. Then there is Elastic Cache, Neptune, and a lot of other services as well. Then the migration and transfer section is the one which has a set of services which allows you to transfer your data from an on-premise environment to the cloud. In this case, the Amazon Web Services. So you have a set of applications that are there in your traditional environment, maybe an on-premise environment inside your organization, and you want your applications to migrate to cloud. So as for that purpose, you want to transfer the data and associated stuff. So for that purpose, there are a set of services that are offered by Amazon Web Service that fall under this category. So we are not going to cover all this in this section. I am just giving you a quick overview of what all these services are. That's the purpose. Then the networking and content delivery. This contains a list of services that that helps you to create the network and such kind of things, like whatever resource we are creating in Amazon Web Services that need to be inside a network. So for that purpose, a VPC can be created. Similar way, there are a lot of other services like the content delivery network and CDN, and all sort of stuffs are there inside this particular section, the networking and content delivery section. Then the developer tool is a set of tools that are offered for the developers. It's kind of similar like the DevOps system, where you have the provision to create the work items, then the source code control. Your code can be committed into the source code. Then the code artifact. Once the build has been done, a set of artifacts is created and you can store that. Then the build and deployment pipelines are there. A lot of then Cloud9 is another one integrated environment where you can do all the different steps. So the similar service in Microsoft Azure is called the Azure DevOps. In Azure DevOps, you have the option to create work items. Then you have the option to store the source code as JIT or TFS, and then you can create build and deployment pipelines. Then once the build and deployment pipeline is done, you have the provision for test and other things. So similar kind of service is what this developer tool category is all about, different kinds of services. So if you want to, if you're interested in knowing about a particular service, you can just search that and the documentation will be available from there. For example, if you want to understand about what is the code commit service, you can just search for code commit, and that will pop up with a page that you can go for. And yeah, this one, AWS code commit, and what that is, that offers. So all the required documentation is provided by Amazon Web Services, then which you can go through and you can understand. So what are the offers that are provided by this particular service? Like if up to 5 active users, it's free per month. So this is the similar for Azure DevOps as well. Then what are the other benefits that are provided by this service? In this way, whatever service you would like to know, you can share that, you can search that, and there will be a good documentation that is provided by the Amazon Web Services. Then we can look into another set of services. We were up to now this developer tools. Then the next set of services is like the customer enabled service, which allows a set of service to for situations where you want to interact with the customers and those kind of stuff. Then the robotics is for robotic app development. Then the blockchain, if you are interested in developing the blockchain application, there is a service called Amazon Managed Blockchain Networks, which can blockchain service which can be used for that purpose. Then there are other services which are easily understandable from that name itself, like the satellite, then the Amazon bracket, then the management and governance. This offers a set of services which help to manage all the different Amazon Web Services that you create, whether it may be in on-premise or it can be in cloud. Whatever type of services that are part of AWS, you can manage using these different types of services. For example, this CloudTrail is one such service which can help you to capture the logs that are associated with the different services. So when you create different services, or when you use different services from Amazon Web Services, you want to know how that particular resource is functioning, in case if an error happens, or whether that is functioning correctly or not. So all those kind of things you can verify, provided if there is a CloudTrail connected to that. You can have another option as well, but Amazon provides a service for that purpose, which can be easily integrate into your existing Amazon Web Services, which help you to understand how this particular service functioning, and all the associated application logs and the resource logs and everything can be captured and understand from one single place called the CloudTrail. So in the last episode, last session, while we discussed about the different services in Microsoft Azure and Amazon, we were discussed a bit about the CloudTrail. So feel free to watch that session as well to get an overview. So this is similar to the application insights in Microsoft Azure. So all cloud providers offer a kind of a similar kind of services, but with a different naming, and some cloud providers offer services a bit differently than the other. So that's how the things are happening. And then there are a set of other services called the media services. This is used for the media, implementing the media streaming and the transcoding purpose. Then going back again, going to the top, there is another set of category called the machine learning, which has a set of services which supports the machine learning applications. So you can go through all that. Then analytics service is there. Then the security, identity and compliance. This has a set of services that can help to implement the different security and the identity mechanisms in Amazon Web Services. We will be discussing a few of these in today's session. Then there is the cost management. This can help to plan your cost while using different resources in Amazon. You can set budgets, alerts and everything from within this thing. There is a cost. In addition to this, there is a cost calculator that is also provided by the Amazon Web Service, which can help you to ascertain the different cost that you are going to have while using a particular resource. So that can help you to plan and budget these different things. Then the front end web and mobile offers a certain set of services that help for mobile and web application. Then there is an application integration which helps the other resources to integrate within each other. So these are kind of applications. For example, if you have a particular data in one place and if you want to integrate that with another on service, you can use this set of services for that purpose. And the business applications are there, customer management and business. Then there is a category called the Internet of Things, which has a set of services that are used for the purpose of Internet of Things. And similarly for the game development, there are another set of service. There is another service. So in this way, there are nearly around, I don't know the exact number, nearly around 176 services out there. Some of them are looks like similar service. Example, the Elastic Beanstalk and the Amazon Lightsail, it's kind of a comparatively similar, but those are used for different purpose. Similar way, there are a lot of services that overlap each other, but other than that, these are the services. These are the overview of some of the services that are in Amazon Web Services. Now we have to understand the concept of region and availability zone. So in Amazon, not just in Amazon, in whatever cloud provider, the way by which they store these resources is inside a data center, and that data center must be inside a region. So the entire geographical area can be subdivided into regions. And there will be multiple regions. For example, if I click on here, I can see a list of different regions out there. So one should select the closest region that are associated with that are closer to them, so that way they can save a lot of cost. And there are different regions out there, and within each region there will be a set of availability zones called the data centers. And there are a couple of availability zones inside each region, which are connected to each other through high speed connectivity. And these availability zones are independent, and they have independent cooling and power associated with each one of them, and they are redundantly connected to each other through high speed connectivity. So this is an overview about the cloud application. So the advantage as an application developer you would get from this kind of service is, for your application, you can use any one of these services as you like. For example, you are developing a web application and you want to store some data in the cloud. You can go for either a SQL or kind of a relational database, or you can go for a non-SQL database. So all those are provided here in the database section. So if you are interested in a relational database, you can go for RDS. If you are interested in a NoSQL form of database, you can go for DynamoDB. And similar way, other options are also out there, like the Amazon Document DB and other. Then other thing is, like, if you want to have logging in your application, you can go for this CloudTrail and such kind of things inside the management and governance. Then if you want to store plain files like the image or some sort of static files, or in the case of a image processing application, you are uploading a set of images and you want some location to store that particular images. So for that purpose, you can use S3 or some kind of thing. If you want to deploy your application as a container, you can leverage any of these services. So this is the advantage of cloud, where you can on demand request some service, and you can start with a smaller scale, and then you can scale that up to higher as per your requirement, and then you have to pay for only what you have to use. So you don't need any upfront cost like the traditional form of development, where you have to bear all the infrastructure charges associated with that. And in cloud also there are different models like the IaaS, then the PaaS, and the software as a service model. So IaaS is like everything will be provided by the in the case of infrastructure as a service, the associated infrastructure will be provided by the Amazon, and you have to set a certain kind of things, configurations like you have to install the particular operating system. You have to set the different permissions and such kind of thing. And as we go further into the PaaS kind of model, we can directly use a service. In that case, we have to set some level of permissions and some level of settings, but majority of the underlying things will be handled by the cloud provider. Then as we go through the software as a service, the majority of the underlying things will be handled, just like when we use a Gmail or some kind of mail, we can either have that mail set up inside a kind of an infrastructure as a service like a VM, and then we can set up the mail server, or we can go for a software as a service like some form like the Gmail or the Outlook, and we can use their service straight away. So the SaaS is the preferred way by which everyone is interested in. And as the applications are evolving from the on-premise to the cloud, it moves through a phase of different models, like the different kinds of models like the infrastructure as a service, then to the PaaS, and then to the SaaS, and that way it will move. So then now let's look into this particular infrastructure, this security, identity and compliance section. So this is the section, this is the set of services we used for implementing the authentication to a particular resource in the Amazon Web Services. So as part of your application development, you may need different services, as we saw earlier. Sometimes you may need this some set of VMs you may need, or sometimes you may need an S3 bucket, or sometimes you need an RDS or a DynamoDB or whatever, according to your requirement. But how you decide who will access to that particular resource? So you set all that inside the inside this, not this one, okay, inside the identity and access management. So this is one of the service that we are going to use for setting identity and access management things. So this is important while developing an application, because your application is running in cloud, and you want to make sure that whoever is going to access should have the required permissions for accessing that particular resource. So in this way, you will set a policy like only those allocated to access a particular resource should access, and no one else. So that is the purpose of this setting this identity and access manager. So how we are going to set this identity and access management is through this way of user groups and users. So your application will be using by a set of users. So you can set the users, and you can apply different policies to those particular users. So that is fine for the purpose. But if you have a lot of users, it will be good to create a user group and then associate the different users to each particular user group. So that way you can easily manage. For example, I will explain. If you have a set of user like user 1, user 2 and user 3, all those are developer person, and they need to access to some storage like the S3 or RDS, and they should have only the read-only access. So you want to set a policy for them, okay? And similar way, there are another set of persons like the support user 1, support user 2. They should have access only to a particular S3 region, or some form of other service like the some form of dashboard or some particular VM. So we need to set a policy for them to access that particular resource only. So one way by which you can set is you can create different users and you can set the policies to each different users, but that will be difficult when a new user or new developer joins the team. Suppose you set these permissions, this access to read-only access to S3 and RDS from for these three users, and if another developer is going to join your team, then you have to set that permission again. So instead of that, the other way is by which you can select, you can create the different user groups, like you can create a dev group like this, dev group, and you can create a support group, and you can set policies for these two groups, so that whenever a new user is joining your team, you can add that particular user and assign that particular user to a particular group, so that instead of setting policy to each and every user, you can set that to a particular group, and you can add users to that particular group as well. So that is the concept of this user group and users and user group. And there is another one concept called the roles. So these are set of human users who are going to access the system. But what about such times when you need, for example, your application may have different components like a web interface. Then it may have a DB. Then it may have a set of VMs associated with that. So whenever a particular program that is running inside a VM, particular application that is running inside a VM needs to access to this particular DB, then you can create the roles as well. So this is another form of security in addition to these above two types of user securities which we discussed earlier. And that way your application can access to that particular whatever required resources, and you are interesting a security in that way as well. So these are the different ways by which we can set the security in Amazon Web Services. So you can set policy for these as well, these roles as well. So either you can apply the policy to this user groups, or the user, you can specify policy to each and every user, or you can specify policies to the roles as well. Policy is the one which defines what one should access, which resource that particular user or that particular roles or particular user group should access. So that is the idea of this role. So let's create a user group and we can move from there. So let's create a group called we have to provide a group name. We can give it like dev group with read access to S3. We are dealing only with a simple example here, so you can tweak that according to your requirement. So there is a root user there, that is me, and in addition to that you can create different types of other groups as well. So once that is okay, so once that is created, then you have the provision to attach required permissions as well. So the purpose of creating this group is to assign some permission to that group, so that they will be having only read-only access to S3. That is our aim. So for that purpose, Amazon already have given a list of permissions predefined. It's kind of a ready-made template by which we can easily assign to this particular group. So in case if you want to have an explicit policy, you can define that as well. So these are some of the existing policies that it's kind of a predefined template which you can easily apply to your case. In this case, let's check whether any such policies are there, and then we can assign that. So let's search for that. So when I search here, okay, one such policy I found, like the Amazon S3 read-only access. So I select that and then I create that particular group. So now the dev group with read-only access to S3 group has been created, but there are no users added to that, but we have set the permissions and everything there. So if you want to confirm what permission you have set, you can go inside that particular, you can drill down into that particular group and you can check the permission there. So the permission is this one, and if you want to understand what permission is there, you can click on that and you can understand what all permission has been set by AWS. It's kind of a predefined template, but we can look into that particular JSON and we can understand. It's kind of a JSON structure by which this is the structure they follow. Like the effect will be allow, and S3 get and list will be kind of a read-only access we are allowing for this particular policy. So you can change this policy as you like. You can change that to a different one. So that is also possible, or you can set an explicit policy as you like. So all those details are there in the documentation, by which you can go through there and you can change. Then we can create another set of group with the full permission as well. Then we can add a few users and let's see whether that is working or not. Then let's create another dev group with full S3 access, and here I can search by the S3 again. So this is the way by which you can check whether any existing template is there or not. So if you want to access a particular to VM, for example, VM is another resource which is called the EC2. So if you want to check that on, you can check that as well. So now the filter is there. So if you want to have that particular dev user to access only to particular EC2 instance, you can have that as well. But if you want to have a custom list, you can create that as well. There are provision that are given in this screen itself, where you can add custom rules or policies as well. Now in this case, S3, let's clear this on a bit, and we can go ahead with the S3 full access. Okay, then let's check dev group with the full S3 access. Okay, fine, and then create the group. So now 2 user groups are created with the required policies set. Now there are 2 users who are joining to this team, and I want to access I want to add those particular users to a particular group. I can do that as well. For example, a new user is going to join. I can add that particular user. For example, let it be a dev user 1. So what type of access I should provide, like programmatic access or AWS management console access. So I can define that as well. If you are creating a username that you want to particularly use for accessing from a program to a particular resource in Amazon, you can use this programmatic access, where it enables an access key and a secret key. But if you want to assign that to a particular person who want to access that to see what all services are there, or he want to manipulate some of the services, it can be provided an AWS management console access. So this will be created, and let's create a custom password as well. So in this case, I'm going to type a password here, and once that is done, you can create an auto generated password as well. And let's change this now. Then next, permissions. Then say now it is asking whether I want to associate that particular user to an existing group. So we already created 2 groups. So the first user I want to assign that to the read access to S3 group, and we can set the next tag. So this is another way by which you always see in Amazon Web Services resources, where you can set a tags so that you can help to organize, track, or control access for this particular user. So this way, for example, if this is a kind of a user where that user is particularly working on a particular area or department, you can set those kind of tags here. For this case, we are just leaving it default, and then go to next, and then let's create that user. So this is the user, dev user 1. So now that dev user is created, let's add another user as well. Okay. Okay, then okay, let's close this. Then okay, now two users are there. One is the root user, which is me, and then the new user, which is the dev user. Then I'm going to add another user as well, which is dev user 2, which I want to have full access to the S3. For that, I can add them to a full access group as well. So let's create a password for that particular user. There is a provision that if you want want to add a new user without having to set a custom password, you can select this option, like the auto generated password, so that that details will be automatically emailed to that particular user only, and there is no need to specify any password in that case. But here, for the sake of demonstration, I want to know that what password I am using, so I just created that. And you can have this, you can set these additional options as well in case if required, and then click on next. Then here it is asking whether this should be assigned to a particular user. So let's assign this to dev group with the full S3 access. Then next. So leave the tags for the moment, and then next click review, and then create user. So it will take a few seconds for that particular user to create, and once that is created, then you can go back to that which one that identity, and where is that? Yeah, here, identity and access management, and you can refresh that particular page, and you can now view the three users there, like the root user, then the dev user 1 and dev user 2. So let's access this this particular user, and let's see whether I can whether the permissions or the policies are applied as per required. So if you look into here, you can see that this particular user has only read access to S3, and while the dev user 2 has full access to S3. So let's log in as this user and check whether the policies are applied as properly or not. Okay. Okay, let's go to the dashboard again. So if you log to the dashboard, that will provide you the console URL for logging in as that user. So I am switching to an incognito mode, and I'm going to log into that particular user. So the username is let's see again, what is the username? Dev user 1 or something like that. Dev user 1. Password I remember. Okay, then dev user 1, then password is 1 2 3. Let's see if password is correct. It will allow me to log in here. So this is the user who don't have the full access to S3. Let's create a S3 bucket for now, and let's see whether the policies are applied or not. So if everything goes fine, I will not be able to create a new S3 bucket. So goes to the S3. S3 is a storage option. So tomorrow there will be a session for understanding a bit more about the storage and the RDS. So that is also at this time around 7 p.m. to 9:30, and you can watch the session to get a more overview about the storage and the relational database services that are provided by Amazon Web Service. So let's create a bucket here. So you had you have to provide a unique name for your bucket. In case, let's create my development 01. Let's add TVM also, so that I can create. Then so other options, you can add that or you can leave that. For if you want to add tags, you can add that as well, for the purpose of easily managing that particular bucket later. If you want to set encryption, you can enable that as well. So encryption is the way by which you can protect your data while that is at rest. Means once from the application, user will be sending some data, or the application will be sending some data to this particular S3 bucket, and once it reaches the particular bucket, it's a kind of a state called data at rest. So at the time of rest, how we want to encrypt the data is what this defines. So we can enable this or we can disable that. If you enable this, we have the provision to encrypt that particular data, so that another resource, or even if the Amazon itself may not able to view that particular, another user who is not authorized to that, or even Amazon itself not able to have an idea about what that particular data is all about. So in case if you want to encrypt, you can have that option here. We will discuss about this a bit later. So let's create the bucket when we come a bit later, when we dive more detail into the access permissions and encryptions a bit later in this session. So let's go to create a bucket, and now you can view that it is failed to create the bucket because the access is denied. This is because I have set this user only read access, so that this user will not be able to create a particular bucket in Amazon resources. This way we can set the required policy so that only the authorized persons will be able to access your particular Amazon resource. So let's log in as that other user, and let's see whether they will be able to access the particular resource or not. So let's close this. Again, just copy this, and we can go to that incognito mode, and let's remember what that username is, dev user 2. Okay, so let's create a new incognito, and let's log in as that user to see whether that particular user has the right to create any. Okay, 1 second. Okay. Dev user 2 and provide the okay, now it's logged in. Okay, we can follow that same validation steps which we done earlier for that other user. We can go to S3. So the way by which you can access that particular service is either through this service drop down, or you can straight away type that service name here, and you can click that and open. Okay, then I'm going to create a new bucket here. Something like that. Then let's leave all the other things as default, because we are interested only to know about whether this user will be able to create the bucket or not. So let's create. So there's some issue happened, access denied. Let's check what has happened. So that particular users, dev user 2, this should have full S3 access. Okay, maybe this user won't have the permission to create that particular resource. By default, the permission will be denied for all the resources for all the particular users we are creating, unless we specify any particular access for that user. So let's see what all are the different there. Create. So let's see whether any create bucket is there. I think the option for creating bucket is not there. List bucket is there. So this is how the option to create. Okay, let's add another policy, whether we have the option to check that. So let's create a policy. Not this one, sorry. Let's go to that particular user group, dev group with the full S3 access, then permissions. Okay, let's say add permission and attach policies. Let's say bucket S3. S3. Okay, 1 second. S3 read only, S3 outpost full access, storage, quick access, 3 storage, and it is read only. Okay, I think I need to look into that. I think some permission, specific permission needs to be set for that purpose. So the way by which policy set is like this, and we can go through here and set policies. Let's check whether any other way by which we can add this permission. 1 second. User groups, dev group with full S3 access, then permissions, then add permission. Let's create an inline policy. Here we have the provision to choose a service like S3. Then let's create all S3 action list, create group, action, 5 more action, then all S3 actions list, read tagging, right? Okay, one more action to provide. Okay, fine, let's leave that as default. Then review policy. Okay, so this is an implicit policy we are setting. We have the provision to add a ready-made policy which is defined by Amazon, as well as we have the provision to create a policy like this. For example, if we want to add a particular S3 policy that allows the access like this, let's see this as well. Let's add additional permissions if any. Choose let's leave this for the moment. Then review policy. Good service. Okay. Okay, I will check that and update that later as a link below this video, so we can move to other sections. So basically this is like this is the way by which we are defining the permissions here. Might be the permission issue which we need to explicitly set for creating that bucket. So that is why it's show like this. So let's try once again whether we will be able to access. So again, let's log out and check it. It's dev user 2 itself, so there won't be a problem for that. Let's see whether what permission is applied. Dev groups with the full access, dev user 2. Let's say it's dev group with full S3 access, then dev group with full S3 access here, then permissions. It should have the full permission here as defined. Let's see the policy again. Some full access, attach policies. Let's see whether any other playground other option is there. S3 outpost will outpost read only. Okay, we can check that later, and I can update that below this video. So we can move to other areas, and then we can cover the other sections as well. So this is the way by which you are setting permissions in Amazon Web Services using the identity. So for making the identity set easier, there is the concept called the user groups and the users. Then you can also set the roles and associated policies underneath that. Let's once again create this one and see whether any change there. One. Okay, I will check that and update. Okay, so let's go to the other area. We can understand about the different other services that are provided by Amazon for this particular purpose. So now you have seen that an application can have access to a particular Amazon resource, and you can explicitly set permissions through this identity and access management. But there are cases where the organizations or places where they are having a lot of users, maybe a set of Windows users who already have an associated Active Directory in place that they are used inside the organization, and they want to migrate to this particular Amazon Web Services, and they want to use the access rules and other kind of permissions. So for that purpose, in addition to this identity and access management, for the set of the Microsoft Active Directory kind set way of setting access and restricting permissions, the Amazon offers the provision of directory services, which can be viewed from the security and identity and compliance. Then there is a service called the directory service. I think it's not there. Let's search for that directory service. Yeah, so there is a service called the directory service. So this helps to host and manage the Active Directory. So this service provides it's a kind of a managed directory service, and we can think of it as a kind of an Active Directory by which it can have the provision for to work as a simple Active Directory, or it has the option to work as an Active Directory that your already existing Active Directory can be migrated to, and this can be integrated. And this has an AD connector, Active Directory connector, which enables all the different other resources to connect to the particular which enables all the other different resources to have this authentication in place, so that only the required users who are under this particular Active Directory with required permissions will be able to access a particular resource. So that way you can set this as well. So this is another service which enables you to integrate the Microsoft Active Directory into Amazon Web Services. So you can this is a kind of a managed service, and you can set up this directory so that all the different resources in Amazon can be authenticated with the help of this particular directory. So this is helpful for organizations who are already using some form of directory service like Microsoft Active Directory, and it has connectors as well, that AD connector, which help to connect with the different other services. And this is a kind of a highly available service by which if the service hosted in one particular area fails, it will be automatically transferred to another service, so that the user won't experience a downtime. And this directory service will be compatible with all the different other services in the Amazon as well. So this means that existing Microsoft Active Directory users can use this particular directory service and that way they will be able to connect to the different resources in Amazon. So now let's look into some of the other strategies we can use for this data protection or identity. In addition to identity, we also want to protect our data. So this identity is setting for security, because you want to ensure that as an application developer or your organization want to make sure that only the required users who have sufficient permissions should be able to access a particular resource. So that way that issue will be solved using the identity and this kind of directory services, by which you can set all those things, and you can set the required permissions, users, user group policies and everything. And if everything is set up properly, then only the required users will be able to access a particular resource in Amazon or AWS. But there are other things also need to be considered about the data protection. So if you want to, one of the things you want to consider about the data is some of the compliance required, some of the organization compliance standard requires that particular data should be in a particular region, should be within a particular region. So how you can ensure that is you can create these kind of services in a particular region, and that way you can enforce that particular compliance in place. So suppose if you have a requirement that okay, your data should be stored in a particular place, say example in Europe or somewhere, and you can have that you can select that particular region here, and once that is selected, then you can create a required resource underneath that particular region. So the cloud provider, here in this case Amazon, will store that particular data in that particular region. So your organization compliance standard will met, and that way the data will be protected and does not leave any particular place. So that will be within that region. That is one way. Then another way by which you can you can protect the data is through encryption. So there are different ways for doing encryptions. For example, let's clear this out. So encryption, let's talk about encryption and decryption. So we have already seen different other practices like the identity. Now for the purpose of security, we talked about the region concept. Then the other thing which we need to understand about is encryption and decryption. So this is also an important concept which needs to be aware of while to protect the data. So there are different types of encryptions you can set. One is like a kind of a server-side encryption, and another one is like the client-side encryption. So let's understand first about the client-side encryption, and then we can come up about the server-side encryption. So this client-side encryption is very easy to understand. Like in your application, maybe you have a C# application or a JavaScript application or whatever language you are comfortable with. You encrypt the data at the client side itself. For example, if you have a data like this is a secure string, so you encrypt that from the client side itself, so that it will look something like this. So the user or the person who read this doesn't get an idea about what all this. So you have that particular algorithm and everything which you define on the client side, and you will encrypt that particular data and then store that data inside the cloud provider. So that way you can protect the data. So that is one approach. Then the other thing which we are going to discuss here, or particularly important from the cloud perspective, is the server side encryption. So let's look into that a bit. So let's see how the cloud providers are protecting your data you are going to store. So two types of data are there, like when your data is there within your application in your local client environment. For example, if this is a React application with a web interface React application, let's say it's a React web application, and when you type something on to that particular form in the browser, that data is there in the client side, and that data is rest. But once that particular data is leave from your application, we are storing that application, that particular data in cloud. So in cloud, you will be storing that either in a form of some types of data are stored inside a relational database systems, or sometimes it may be a NoSQL type of services we will be using, or other times if in case of an image file or something like that, we will be using a kind of a service like S3 or EFS, or kind of a different service we will use for that purpose. So in all cases, once that particular data has left this particular client side, that is the browser, then that data is moving. So from here to this particular area, it will be transferring through the HTTPS. So how we are going to ensure that protection is either through a way of called TLS or SSL certificates. SSL certificate is the one which we will be using here. So that way, that moving data, that is from the client side to the server side, that data is called the moving data, because that is transferring from here to here. This can be think of as a web application, and this can be think of as a DB side or something like that. For the sake of simplicity, let's understand like this. And then once the data has been transferred from the web application to the DB side, it will be going through a channel, and we can protect that through SSL certificate. So that is one approach. SSL and TLS etc. can be used. So this is called data encryption, data protection in Rust, data protection while moving. So this data is moving data, and we are protecting that this way through the case of SSL certificate or TLS. So once that data has reached here, how we are going to protect the data? So that is another thing which we need to be aware of. So we can leave aside all those things. I hope this is clear. If anyone have any doubt on this, please let me know. I can clarify that as well. So for the client side, we will be using some client side algorithm, and we will be encrypting the data. And once that data left the client, it will be protected through either the SSL certificate or the TLS. And once that data has reached the server side, that is the client side, how the client going to handle, or how the cloud going to handle that particular data to secure that data, or how the cloud is going to encrypt that data, is what going to discuss next. So there are different ways by which the cloud is going to, particularly through an encryption key, and that cloud offers two options for that. You can set an encryption key, and that will be available for almost all the services like S3. Then it can be an EFS, and elastic block storage. So this is used for the case of VMs, virtual machines, then other kind of things as well. So for all these things, we can set a encryption key. So encryption key, how we are going to set is like, you can either provide a key by your own, or you can let the cloud provider, in this case it's the Amazon, to have a key generated by Amazon itself. So that way your data will be protected. So whenever your application will be saving some data to cloud, in the case of S3 or EFS or EBS or even RDS, relational database system, cloud will automatically, the cloud provider will automatically encrypt that data using that particular key, and then it will store the data, and that way it ensures the protection. And whenever we are going to read the data again from the this particular services, using that particular key, it is decrypting that particular data back to that whatever application we are giving. So that process is transparent to us. It is happening, that process is happening underlying, and we won't be able to know what is happening behind the scene, but we can define how that particular key should be generated. We can either let the AWS generate the key for us, or we can provide a custom key. So if you provide a key, or if you let the cloud provider to generate a key by them, so it will be generated by a service called Amazon Key Management Service. So this is a service by itself, and it has the much more broader capability than creating this particular key. So let's see how that will be happening. Let's go to a particular S3 bucket and let's set an encryption there. Now I am logged in as myself and I have the full permission. So let's go through an S3 bucket here. I think already we earlier identified an issue whether we won't be able to create a bucket. So I think I have the provision to create a bucket. I think from the policy perspective, the S3 full access may be the provision by which we will be able to add a new item into S3 bucket, and we have the provision to delete a particular item from the S3 bucket. I think that is what mean by that full access, I think. And with the read user access, I will be having only the provision to delete a particular with the read only permission, I will be having the provision to only read from that particular bucket, I think. So that is what that error happened. So I will check again and update it beneath later. So let's go here and let's create a bucket for the moment. So my application bucket tvm01 or something. I can select a region here, then I can choose the other options if I want. Okay, called public access, then I can process. So here you can enable the encryption. So this is a server side encryption which we are going to define. So I am going to tell the cloud provider that okay, whenever a particular object or data is saved to the S3 bucket, that should be encrypted, and it should be encrypted with a key. So let's enable that, and when we enable that, it shows what type of encryption key we have to set. Like it should be an Amazon S3 key. That so the description is also provided here, like an encryption key that Amazon S3 creates, manages and uses for you. So you don't have to bother about anything and it will be created. But sometimes there are certain requirements, like you have to set a key, and then that time this Amazon AWS Key Management Service key, you can set that there, and it will be read by this particular S3 for encrypting and decrypting your data. So in this case, let's okay. So if you enable one more thing I want to explain here. So if you enable the server side encryption, there are different types of encryption. So this is the default encryption we get when we enable the server side encryption. It is using an SSE S3. It's a way by which Amazon default use an kind of an encryption algorithm called, I think, AWE or something. I think some kind of algorithm that it uses, and it sets the data. It sets the encryption key, and it will be automatically handled by Amazon itself. But we have another provision also by which we can choose an AWS Key Management Service, and this will be having associated charges along with this. So if you enable that, so there are multiple options, like so this is like the default key that is managed by the Amazon itself, and it is a basic form of encryption. But if you want some advanced form of encryption that is protected by AWS Key Management Service, you can select this. And in this case, if you leave this on here, automatically a Amazon Manager Key will be automatically created for you and will be stored inside that Key Management Service. Or you can have the option to enter a custom key in that Key Management Service, and you can read that from there as well. So if you create a custom key, then you have to provide additional options. So let's leave it default like the AWS Manager Key, where AWS will automatically create a key beneath the scene, and it will use that key for encryption. So in this case, it is using a simple form of encryption to default handle that. So this is the recommended one which most organization use, like the AWS Key Management Service or the or the custom key which you can provide through the AWS key management service. So in this case, that AWS key management service key will be created by the Amazon, and it will be automatically managed behind the scenes. But if you want to provide a custom one, you can have the provision to give that here. So let's leave it here and then create a bucket. Again, some access issues there. I think it's related to some permission issue here. Let's identity and management, PRX access denied. Okay, fine. Let's move to the default area, global net selection. Let's move to another location and create there. Amazon key management service. Okay, then okay, now it is creating the bucket. So I think earlier the issue happened because of this. Maybe the region may be wrong and I created that in a wrong region. So maybe due to that the issue happened. So now a bucket has been created with the encryption set, and the key will be managed automatically by the Azure, the Amazon Key Management Service. So now that bucket has been created, so we can look into that the key management service as well, whether any particular key has been created by this Amazon. So let's see here. So this is the AWS Manager Key section here. So if so again the permission has been set, changed default to here. So let's change that to another area. Okay, so now I can see a list of the keys that are used behind the scenes. So this is the one which is created by Amazon, called the AWS Cloud S3 key. So this is used for encrypting and decrypting the data, and that is created beneath the scenes. So let's log out, and we can log into that incognito mode, and we can check once again that other issue we faced earlier, like the cloud user dev user 2 won't be able to create a particular bucket in a particular area. So we can check that once again and come back. So we are interested in dev user 2. So this dev user 2 should have the full path. Let's check the policies again, and we can see whether okay, it has Amazon S3 full access. So it should be able to create that particular S3 there. So this region permission is due to an issue which happened for me because of some permission setting. So in your case it won't happen. So let's go back to that dashboard and use this to log in. Dev user 1, then okay, 1 2 3. Okay, sorry, not dev user 1. Again, I forgot to log in with the correct user. It should be like dev user 2. Let's log in. Okay, dev user 2, then password. Okay, so if everything is correct, it will help me, it will enable me to log in. And let's change this to US East Virginia. That's fine. Then let's create a S3 bucket in that particular area. Okay, fine. So one bucket is already created, that is created by me. So let's create another bucket from this area. like my development bucket tvm02. So this has to be unique. Let's select the AWS region as this one, and let's keep the other things as it is, then create this. So see, now I will be able to create that bucket because I have the full permission. So I think that cleared that earlier issue we faced. So earlier in the demo we faced an issue like we won't be able to create, we were not able to create a particular bucket, and it shows an access denied permission, even though this particular dev user 2 has full permission to access the create the bucket. So the issue happened because of a wrong region that I was in. So this happens only to me because I have set a certain set of permissions in a particular area, and it won't applicable to you. So if you have the required attached policies properly, so you will be able to authenticate to the resources as per defined in the policy. So in the earlier case, we had two users, like the read user as well as the full user. So with the read user, I won't be able to create that particular bucket, while with other user who has the full permission, that will be able to access the particular that will be able to create a particular resource, whatever. In this case S3, it can be whatever resource in Amazon that you can create, or you can set policies, and according to that way it will behave. I hope that makes things clear. So now let's close this whole thing. So we were looking about the encryption and other things in S3. So while creating a bucket or S3 bucket, or while creating a VM, or what other forms of services as well, to protect the data, you can have the provision to set a key. So once you set a key, you have the additional option whether you should have a default basic level of encryption, or you want a bit advanced level of encryption using the key management service. So in this case, I chosen the key management service as the encryption, and that way I set an encryption, and we have verified that by looking into the key management service as well. So there a particular key has been generated by the AWS for the purpose of this particular bucket. So let's open that again, and we can go into the management section. Not management, the properties section. So here the default encryption, if you see, it's now the AWS Key Management KMS. So the key is automatically generated by Amazon, but we have the provision to set a particular key as we like. So we have the option to edit as that well. So if you want to switch back to the default Amazon S3 SSE S3 encryption, let's check this as well. So this is the default encryption, protecting the survey and manage encryption key S3. It uses a kind of this 256-bit advanced encryption standard to encrypt your data. But if you want a particular key also that should be associated to encrypt your data, you should select this one. If you want this one, there won't be any key, there will be a key, but it is a kind of a basic encryption using this AES 256. But this will be a separate one that is managed by the key management service, and behind the scene AWS will create a key. AWS key management service will be create a key, and then that will be used for encrypting and decrypting your application and the data. And this can be used for compliance purpose, and this particular encryption will be supported for many of the services. Like the on service is the one is just to be discussed, like the S3, which is a storage service in this Amazon. Then another service is called the EBS. So let's search for EBS. So EBS we won't be able to provide we won't be able to access directly. So for that we have to go inside the EC2, then we have to select the EBS on the left hand menu here. Okay, elastic block store, this one, and we can set we can add a volume here, and we can set encryption as well. So while creating the volume, you have the provision for encryption as well. So you can select using a default key which is provided by the KMS, or you can specify another key in key management service and use that as well. So this is the one which Amazon created for us while we creating or defined on in the S3. So if you want another one, you can create that in the key management service, and then you can use that, select from here to encrypt this volume. So this is the EBS. So this is used for attaching, elastic block store is used for attaching a particular volume to your existing VM virtual machine. So in AWS term, it is called the EC2 or Elastic Compute Instances, EC2 service. So this is the one service which they came first in 2006, and then the rest of the services are added on top of this. Similarly, another service is called, if you want to use a Windows file system in the cloud in Amazon Web Service, you have the provision to use an FSX. This is the kind of a Windows file system, and here also there is a provision to set the encryption key, and that can be used from the Amazon Key Management System, EMS, yeah. KM, sorry, not EMS, KMS, yeah, Key Management System, yeah. And there is another one service called S3 Glacier. So this will use a encryption by default. So you can create that as well. Then let's look into the Amazon Key Management Service a bit more, and then we can have a break for around 10 minutes, and then we come up to discuss more about the compute instances, compute services in Amazon. So let's look into that key management services as well. So the key management service is equivalent to that Azure Key Vault, and this can be used for managing and storing the different encryption key for protecting your data. So you can use a unique key by your own, or called the customer managed key. If you click here, I am not using any customer managed key, but all the keys were creating by Amazon and managing on behalf of it. So we can use different key management strategies like the Amazon Key Managed strategy, or we can provide a custom key and define that in the key management store, and we can use the other services to have the encryption based on this particular key, so that every time it saves the data, whether it is S3, EBS, EFS, or whatever type of storages that are compatible with encryption, it will store the data and encrypt the data based on that particular key, and after it is saved in that way, the data is protected there at rest. And once when the application wants to receive that data, then the Amazon on behalf of behind the scene, it will automatically convert that particular data back, or decrypt that data back using that key, either of these key, and will be provided to the customer. So this way the key management service acts like a central service for managing the different keys. So how we are going to define the different keys is, this key management service will have a master key, and that master key is used for doing other kinds of encryption and decryption and accessing the different other customer set of keys. So the master key never leaves this key management system, so that way the security is entrusted. And you can also set the logging using the cloud trail, which can be set for this KMS service. For example, if you if you selecting a key, you can have the provision to set logging as well, so that everything you are doing using this particular key management service will be audited using the cloud trial, and that way you will have an idea of what is happening behind the scene. So this particular key management service is ideal to integrate with the elastic block storage, then the S3, then the Redshift, which is another service, so that can also be integrated with this key management service, and the cloud trial, that is the logging, that also can be integrated with this. So the concept is like we will have a master key, and that will be used to encrypt and decrypt the data key, and that will be managed by the AWS customer, that master key. So AWS can create one thing, or you can create by your own different way. So in this case, Amazon created a data master key for yours. But in the case if you want to store a custom key, you can set that as well, and you can use that in the storage section. Then there is another one security service that is provided by Amazon, which is called the AWS Cloud Hsm. So let's look into that as well. Cloud Hsm. I think okay, Cloud Hsm. So this is a kind of a device, hardware device, that can be used for cryptographic operations and key storage, and can be used within a single tenant. So this is an advanced concept. For majority of the basic application scenarios, we will be using this key management service along with some form of storage services or relational database services. But in the case of some particular custom requirements, then there is a provision to use a device for this cryptographic operations and key storage, and that is called the Cloud Hsm. So this HSM will be located in the AWS data servers and managed by the Amazon Web Service itself, but it is isolated inside your particular network. So there are different use cases where that HSM is used. It's used for that identity management, and then from transaction processing that can be used. So all those things you can use that. Then there is another on service called the Amazon Massey. So this is a kind of an AI based service which automatically analyzes the data, so I automatically analyzes the data, which can either be in an S3 bucket or in RDS system or whatever, and it using some set of algorithms, it will identify whether that particular data can make any problem. So you can make different decisions based on that, and you can analyze the data. It's kind of a AI powered service which is used for discovering, classifying, and protecting the different environments that you used for application development. So if your application has a set of different environments, maybe a set of VMs, a set of storage locations and everything, and you want a set of you want a service like Amazon Massey, which you can leverage, and it uses a kind of a AI driven algorithm behind the scenes to identify and discover potential threats. So for example, if someone uploaded a malicious document in a particular blob or S3 location, it will automatically create a alert or warning, and that way you can set certain restrictions, and you can make certain decisions based on that purpose. So to learn more about the Amazon Massey, it's a paid service. You can go to this link and you can learn more about that particular service, Amazon Massey. So that's the easiest definition. Like it helps to discover and protect your sensitive data at scale. When data is going to increase, it there would be a massive set of data, both the moving and the data interest, and this can be used for identifying those particular things. So this is what I defined earlier, like it uses an AI algorithm. It automatically generates an inventory of S3 buckets and details on bucket level security and access control. So it analyzes the buckets using the machine learning and pattern to discover sensitive data such as personally identifier information or such, and it generates the findings and sent to Amazon CloudWatch for integration into workflow and a remedial action. So we can if there is a potential threat there or some sensitive data is there, we can add that to the workflow as well, and that can be connected to different other services as well using this CloudWatch events. So this way different integration is also possible. So if you look into here, application, yeah. Okay. Okay, so we were discussing about the security. Then the next set of services we going to discuss is the threat detection. What type of services are there in Amazon for threat detection? So one such service is called the Amazon Guard Duty. So we can search Amazon Guard Duty. This I'm going to explain all this just an overview, so we'll get an idea. So it will automatically protect the Amazon accounts, workloads, and data with intelligent threat detection and continuous monitoring. So you can go through this particular documentation and see how it is working. It's kind of a continuous analysis of the different logs and then intelligently detects the threats, and it can also help to take the different actions based on that. So that is one service which is called the Amazon Guard Duty. Then the another one service similar to this is the Amazon Inspector. One second. Okay, Amazon Inspector. Let's see. One second. Okay, this is the Amazon Inspector service, and it automatically assess the different applications that are deployed on Amazon, and it also helps to improve the security and compliance of applications by going through details about all those things. Okay, so we can have a break for around 10 minutes and we will come back, and when we come back we will discuss about the compute service in Amazon, which includes the virtual machines, the EC2 instance, then the container, a set of container service, different container services, and we also look into the serverless concepts like the Amazon Lambda and such things. And we will having a break for around 10 minutes, and I will set the timer here, and once we back we can have a discussion on that as well. One second. Timer, yeah. So stay with the session and we will come back after 10 minutes. So welcome back. Okay, we can continue the session. So let's close all these things, and we can look into the different compute services that are offered by the Amazon Web Services. So if you look into the compute section, you can view a list of services called the EC2, then the Lightsail, Lambda, Batch, Elastic Beanstalk, Outpost and all. So we will be discussing a few of these things like the EC2, Lightsail, Lambda. We won't go deep into all these other things, but we can have an overview. We can check an overview as well, and we can look into that containers concepts as well a bit, and that way we can understand the different things. So the elastic scale or the elastic compute is a kind of an 1 second. Okay, so the elastic compute is an approach by which you are having the rental computers in AWS. So you can choose various types of EC2 types. You can choose the virtual machine based on the compute capacity, then the different compute capability. Like if you want to take a create a EC2 or the virtual machine that has a that is optimized for computation, you can choose a computation optimized VM or virtual machine, or in Amazon terminology it is called the EC2. And if you want to create a EC2 or a virtual machine that is optimized for storage capability, you can do that as well. So there are a set of predefined ways by which you can create those VMs, and that provides the flexibility for creating VMs from inside the that create VM portal. So let's look into how can we create a VM. So before we creating a VM, let's understand a bit of the advantages of using such an approach, like a creation of VM, or not just VM, whatever kind of compute we are renting from this cloud vendor. What advantage does it serve than using an existing infrastructure one? Suppose we are an organization and we have a set of resources, a set of infrastructure within us, and sometimes when the consumers reach up to a particular point, we feel a need to increase the load based on that particular customer requirement. So that is called the scaling up and scaling down. So when the customers or the load decreases, we don't want that much instances to run, and we can reduce the instances and we can save the cost. So the concept of scaling up and scaling down, it's the kind of a way of elastically updating the instances up or high down based on the requirements. So that option is provided by this cloud, and it more applicable in the case of compute, where we need a high load to process, or when we need a high storage at a particular time, we can rent that from the cloud provider, and we have to pay only for that particular usage. So it's kind of a per billing model as per millisecond or per minute model as per the Amazon. It's different based on each type of VM. So we can create on such thing, and we can look into all those details. Now let's understand from an example perspective how this solves some of the issues that we face in application development, especially the time. For example, we are developing an application and it requires let's say on VM which do a set of certain calculations and computations. So VM is not required calculations or computations, or you can or in other way you can call that as a processing, something like that. So VM is not required in all applications case, but we are just understanding the flexibility that cloud provides. So for example, if we are using on VM and the application needs to do a certain set of processing. For example, if we are sending a few files to this particular VM, like 100 files or something, and in the VM level, it requires around let's say 10 minutes to process, or 5 hours to process that 100 files. Then it would take around how much? For 100 files to process, it takes around 5 hours to process these 100 files, and that is an ideal scenario. So with the cloud, you can do a different way, like instead of having 5 hours to process 100 files, you can take like 1 hour to process 20 files. You can define your application like that way, and you can spin up multiple VMs behind the scene. So that means instead of having one VM to process these 5 hours of 100 files in 5 hours, you can use a combination of 5 VMs, each processing 20 files at a time. So instead of this one, you can use 5 VMs instead of 1 VMs, 5 VMs, and which process 20 files in 1 hour, and that means that within 1 hour you will be able to complete all the 100 files, because the 5 VMs will be running in parallelly, and that saves a considerable amount of time. And from a cost perspective also, if one VM is going to run around 5 hours, that costs a certain amount, and the same is only therefore even if there is a 5 VMs that is running for around 1 hour. So you can do a certain processing at a faster rate by using this cloud elasticity, and with the help of this on-demand scaling, you at peak times you can increase your VMs or whatever resource you are using. Maybe in this case, in this example, we are used a VM, but in the actual example you may be using some other form of service, like maybe it's a kind of a storage, or it can be a AWS Lambda or a light sail or whatever. It can be scaled according to our requirements, and we can do more processing in minimal time. So instead of taking 5 hours to process 100 files, we can complete around 100 files in just 1 hour through the parallelly running 5 VMs instead of a single VM. And that is possible because of the cloud, because we can instantly scale up and down the required resources, the required compute resources on demand. And sometimes if we want to have a certain set of processing to be done at a particular time, and within a minimal machine, it would take around this much set of time to complete that particular load. We can increase that particular machine to a high-end machine, so that it will do more processing in limited time, and that way we can complete a particular set of processing as fast as possible. So that is the flexibility that is offered by cloud, and because of this reason, the cloud getting more and more popular, and many organizations are moving to cloud, because they can scale up and scale down, and that can save a lot of money and time. So there are different services that are provided. So we will be looking into one such service called the EC2, which is similar to the VM. So if you have a familiarity with cloud and have a background in Azure, so the similar is called the Azure VM, or virtual machine, from a Windows concept. So that's a similar is called the EC2. So let's look at about the EC2 and how it works. So let's spin up an Ec2 instance, and how easy we can spin up an instance. For example, imagine if your application is running, and at a certain point of time your application needs a bit of additional VMs. You can easily spin that up, or in case if you want a VM for your development perspective or test purpose, For some additional VMs you required, you can easily spin up that as well easily from this portal using the EC2 portal. So in EC2, the concept is called launching an instance. In Azure, the concept is called create a virtual machine, but here the concept is called the launch instance. So let's launch an instance here. So once we click on the launch instance, it will ask what type of image we want to create. So we have the provision to have our own image, which can be stored inside the my EMI. So we don't have any AMIs using at the moment, so it's showing empty. Or you can go to AWS marketplace as well and find a list of VMs from that particular area as well. Or you can go for community VMs as well, or we can go back to default the quick start. And if you are creating a free account in Amazon, some of the services are free for a particular period of time, say 12 months or so. So this on particular on Amazon Linux is such a service, such a image that can be used for creating, and it won't cost that much amount. For free, it's eligible for free tier. So let's see whether any other images are available. So see this, the Mac OS is also available. Command lines Amazon S3. I think this is a command, yeah, EM based supported image. A few Mac images are there, then Red Hat are there, lot of services. Then the other type of Linux called the SUSE Linux. Then the Ubuntu server is there. Then the Windows is there, Windows Server base, that is also free tier eligible. So if you look into here and if you create a VM or a EC2 instance based on, I will use the term VM and EC2 interchangeably, but the idea is same. It is a virtual machine, and you can select a particular image, and if you are using a free account, it is always advisable to use some free tier eligible so that you can create some particular VM without incurring additional cost. So let's select this one. So once we select this one, then we have to choose an instance type, like how much CPU we want, how much power we want. So for the free tier, let's stay with the defaults. If you want more power and more processing, you can opt for the other options as well, like nano, medium, then T for micro. Some of the services are not available, that is why it is displaying like this, and metal large. So based on this, the capability also differs. So you can have a look on all these factors, like the instant storage, the EBS, optimized available network performance and everything. So the performance of this one, free tier eligible T2 micro, is low to moderate. So let's stick with that, and let's click on next and configure the instance. So how many instance we want? So this is like how much instance that VM will run. So if you increase the instance, that increase the cost as well. So all the other factors you can change as per the requirement, like the network and all things. So for understanding purpose, you can leave all this default for the moment. And next we can click on add storage. So storage means there is a certain storage that is provided along with this VM. So if you want additional storage like SSD or something else, it is called the EBS volume, which we discussed earlier. When we discussed about the encryption, we understood the concept that we can encrypt a particular storage like the S3 or EBS. In the case of this EC2, EBS volumes can be added along to that EC2 instances, and we can encrypt that as well. So you can add new volumes if required. And the default encryption is not encrypted, but you have the provision to use an encryption key as well, like the one generated by the AWS earlier. So you can use that as well if you want encryption. So for the moment, to let's create a normal as it is, and see this on Amazon showing free tier eligible customers can get up to 30 GB of EBS general purpose SSD or magnetic storage. Up to 30 GB we can use for free trial. So this is now 8 GB, that is enough for our purpose. And next is the concept of adding tags. So tags defines the way by which we can add extra informations to this particular VMs. We will be creating the VMs here, and if you want to categorize that VM for a particular environment. If you are in software development and if you have different different environments like the dev environment or QA environment, you can consider setting a tag like this. This is optional and you can set as per your requirements. There is no mandatory like this, and you can add another tag as well. The advantage of adding tags is that it will be helpful for managing these VMs at a later point of time. Then let's click on next, the security group, and you can add that as well, security group, and what way by which you want to access the system. So if you want to access through an RDP or something, you can have that provision as well. So let's say check for RDP, and you have to set that permission. Then then what all IPs can access these things, that is what defined by source. So your VMs, once you create that, you need to protect it from unauthorized access. So that way you want to ensure that for that purpose you want to ensure that you have to provide a proper firewall in place and IP in place. So for that purpose you have to restrict the IP address that can access this VM, or you can leave it to anywhere, or you can set your my IP as well. So if you click here, my IP will be automatically captured and it will be added here. So this way you can have different options here. Then after that, let's delete this RDP and let's leave, let's set anywhere. So this is not recommended, or let's set my IP. Okay, then review and launch. Then everything is fine. So we have selected the free tier eligible Amazon Linux. You can choose other options as well, but your account will be charged accordingly. And then click on launch. So here we have to select a new key pair as well. So you can choose create a new key pair. You have to create a key pair name like the Amazon Linux EC2 key pair, and this will be downloaded so that you can SSH to this particular instance. So once you download that, you have to create that and you have to download that and store it in your local machine so that your SSH compatible client can able to access this particular VM. So let's click on create instances, and it will take a few minutes for VM to get activated. So let's wait. So now the VM is actually running, creating behind the scenes, and let's go to here. And if you go here and click on the instances, you can view that. So right now it is displaying only the instances that are running, but if you remove that filter, you can view that the one which we just created is now running behind the scene, and we can click on that and we can view other details. So here there are other options like a spot request. We can explain that as well, and then we can go into other concept like the container. Okay. So there is a concept called the EC2 spot. So you can search that here, EC2 spot. So that will help you to run the fault tolerant workload at around 90% less than the normal EC2 price. So this is the Amazon EC2 spot instances. So this can help you to run some of the least important workloads, and it's cost very less. But there is one disadvantage that at any time this can be shut down by Amazon when there is a requirement for someone else to use that particular spot instance. So there is a possibility for interruption that can happen, and this documentation provides some ways by which how to early identify that interruption and how to possibly do all the things before shutting down that VM. So the concept is like the cost will be less, and Amazon will provide you a spot EC2 instance, and it will be around, as they are advertising, it will be around 90% of the regular VM price, and we can use that instance for least fault tolerant kind of workloads. And sometimes Amazon can call that VM shut down, and at that time you can you can identify that interruption earlier, and you can set the different flows as per that requirement. So it's suitable for a non-live workloads, and kind of a some of the use cases are defined here, like a CI and CD testing, then containerized workloads, and because they are all fault tolerant, so they will be able to spin up again. Then some of the web services, image and media, and high performance computing, and all those use cases you can use that. So go through this documentation. Then the EC2 Auto also provides the option to scale the VMs up and down. So scaling is like so you can enable scale so that according to the requirements, the EC2 will be scaled automatically, and you can set that as well. You can set the minimum size and maximum size as well, and based on that it will be automatically scaled and scaled down as required. So you can go through this documentation as well to understand more about that, and it has no additional fees. So this is another one service which the Amazon provides for scaling purpose. Then we can look into the concept of containerizing the application. So before that, let's understand why these VMs are usually used in your application. So VMs are used in many cases. So for example, if your application application's purpose is to capture the different logs or data from some various inputs and process that and then show that in a dashboard. Then for that purpose, for this thing to work out, like data from various inputs and process to work on, either you need a managed service from the cloud provider like the Azure Data Lake or Amazon, a similar kind of Amazon services, or what you can do is you can spin up a VM and install the custom application inside that particular VM and then do the processing. So you need at times in application development, you need to spin up certain set of VMs or the EC2 instances, and that is on use cases of VMs. Then another use cases of VM is like, for example, if you want to test something in a particular machine, if you don't have a machine in hand, then you can use whatever machine which has a browser, and you can use this VM so that you can RDP to that particular VM and do the workload. So that is another purpose. There are different workloads of the use cases of this EC2, but it is a bit costly. That is the one disadvantage of VM. It's very costly because the cloud provider is actually spinning up a full machine from scratch and giving you a full machine so that you can do whatever you like inside that machine, and because of that purpose it's a bit costly. But there are times when you require that, and you can use the such kind of EC2 instances, and there needs time when you want to increase and scale up and scale down the different instances as well. So for that purpose you can use the Amazon EC2 scaling as well. So that will automatically do the scaling behind the scenes, and it won't cost additional amount as such. Then that is one way. Then there are requirements where you have a set of legacy application which has certain dependencies that needs it to be run inside a specialized environment. So in that case also VM is required. VM or EC2 is required. And if you have a lot of legacy applications, maybe that may be created in like older languages like VB or something like that, and if you want to move to cloud, then you may not be possibly use the PaaS service or other service as it is. In that case, you may have to spin up a VM or EC2 and then set up that EC2 to match your requirements, and then set all the dependencies inside that EC2, and then you can move the application, host the application inside that VM, and that will be served to the end user. And if you have a set of service or set of application that is not available in cloud, like for example, if you're in this case, in the case of Amazon, it is not applicable. In the case of Azure, if you want to run a Oracle database in cloud, the only option will be you have is to create a VM and then install a Oracle inside that particular VM, and then the applications will be able to connect to that particular VM Oracle through that VM. So that is possible. So similar way, if there are any specialized requirements or specialized applications your organization have that is not possible to run inside a cloud environment, the only option, or that may not have an equivalent service in cloud, then the only option we have next is to spin up a VM or EC2 and then install the required dependencies and host that application inside that VM so that other applications can be served. So in this way, we can still move that application to cloud, but you have to consider all the cost and other factors that are associated with it. So the next thing which we are going to discuss is about the concept of light sail. So we won't go that much detail into this light sail. So the idea here is like light sail allows you to virtually create private servers. So let's go to that particular page, Amazon light sail. So this is another service. Many of the Amazon services are kind of an overlap, like some of the functionalities that are provided by light sail will be having from other services as well, like the virtual private service that is offered by this light sail, that is available in another kind of service as well, like the EC2 as well. And there are some database specific services that are provided by light sail that are available in other services as well. So there is a set of overlap that can happen, but the advantage by going to light sail is like it is easy to launch and easy to understand from a monetary purpose. Like you can spin up a server and DB fast, and it can be expandable, and it also allows to take the snapshot of particular environment. So it will be worth checking this documentation as well if you are familiar with, if you want to get some familiarity with the computation. So it's suitable for kind of a simple web application. Then websites it's suitable, then dev test environments it's suitable. So you have to analyze the cost and everything, and if it is suitable, then light sail is suitable for some purpose. It's because it's a kind of a set of sub services that offers services like the hosting, then virtual private servers, database specific servers, then it can also be expandable to storage services, then the network components and such kind of things. Now we going to discuss about the container concept. So let's understand why the container concept is important and what help it serves. For example, if you have a web application, I'm just saying an example, it may not be applicable in the case of majority of web applications, but for understanding the concept, I'm just giving an example from the point of a web application, and it have a lot of dependencies, like 10 or 15 dependencies. Imagine, this is just an imagination, just have a web application and have a lot of dependencies, and it have a database also. So the way by which we will be able to host this web application, let's say it's a kind of a React web application with a web API, .NET Core web API behind, .NET Core web API behind the scene. So it has a lot of dependencies, and majority of dependencies in case of .NET Core can be resolved using the NuGet as well. But some custom, let's change this to a .NET application. No need to be .NET Core, because .NET Core has a lot of flexibility. But let's say it's a .NET ASP.NET Web API, older .NET Web API, and it have a lot of dependencies which needs to be installed in that particular server for it to run. Say the dependencies can be, for example, if your application has a preview functionality, and that preview functionality needs a certain set of libraries that needs to be installed in the server, only then the application can use it, and a lot of other dependencies, imagine. And if you want to deploy this particular web application to a hosting environment, it will be challenging, because you have to set all the required dependencies at that hosting environment as well for deploying this kind of application. So if the concept is like, if you pack this application with the dependencies into as a container package, then it will be package. If you pack the .NET and 10 to 5 dependencies as a container package, so in .NET, how you will be doing is like, you will open the Visual Studio. I will just explain from the point of Visual Studio. Like in Visual Studio, while you're creating an application, you have the provision to create the application and enable a checkbox, so that that application will be run inside a container. So the modification that the Visual Studio will be doing to enable it for container purpose is like, it will create a Docker file along with that particular application. So that Docker file contains all the required information, like what sorts of environment it is. That is the base image. It is what that means by the what sort of environment, and all the required information about the associated dependencies and libraries. All that is defined inside that Docker file. So you can check that by creating a new Visual Studio .NET application and enabling the run inside a Docker container, and that gives you a text file along with it, that application. If you look into that application folder, and that text file is the one that enables the Docker, that helps to create the Docker image. So based on that Docker file, automatically a Docker image will be created and stored inside. So it's kind of a package. It's called a kind of a package, Docker package. So that package is self-sufficient. It contains all the required web API as well as the dependencies. And we will, for the front-end application, we will be creating another package as well. Front-end application, we will be creating another package as well. So there will be two packages, one for the front-end package, and another one for the backend, like the backend package. So we will be storing these particular two packages in a common location. So that concept is called the container registry. We'll be storing that particular inside a registry, and we will storing both the packages, like the front end packages and the backend packages. Then once this is done, then we will have the ability to deploy these particular packages in a particular environment called a Docker environment. So this means that if you have the required packages, then it is very easy to deploy, because this package contains everything, and this Docker environment's responsibility is to just spin up that particular package and don't have to bother about any other matters. So it don't have to bother about this Docker environment, don't have to bother about anything, because it contains all the information, including the base image, which is the required operating system. You can think like that, and then the application plus the dependencies. So all those are included inside that package. So you can deploy that to the Docker environment, and that will spin up. So another advantage that this Docker type of deployment provides is, like, if you have a set of users initially, and at a particular point of time, you can call that as peak load, and the load increase up to around 100 or 1000 of users, then you can easily scale up these particular packages to different instances. So initially you may be starting with on 2 instance for front end and maybe 2 instance for backend. Let's imagine in the real scenario it may be in a different way. Let's imagine like a instance for front end and 2 instance for backend. At peak load, there may be need to increase the backend to maybe, let's say, around 10 or 50 instances. Then you can easily do that with the help of this container. So you can easily increase the instances and decrease the instances as like so. The ports can be increased, ports can be decreased. So for that purpose, there are different kinds of services that are offered by Amazon. So we will be looking into such a few of those services, and we can then move into the next session. So let's look. Hope you understand the concept of containers. Once again, we will be having a simple. We can start from understanding about that we have an application called a React application, and we have an associated web API which have a lot of dependencies behind the scenes. So it will be trouble to deploy these particular application, because we need to make that particular deploy environment with all these dependencies, and it will be challenging, especially when we have multiple environments. And it also poses another problem, like when we move from one provider to another, it will be having other issues, like we have to move all these dependencies and all those pipelines to different areas. So if you make your application kind of a containerized model, then it will be easy for you to migrate from one dependency to other. So you can host this web application direct and web API directly in an app service, but that means app service means Azure app service. So that means that your application is particularly tied to that particular app service code. So if you make it a container based model, so the advantage is that you can target and deploy it to whatever cloud providers you want. At a later point of time, you can move to another particular cloud provider, and you can do the and you can make the movement happen with the less changes compared to this other approaches. So that is why many are preferably going for this container based application. So once the application and the backend, this web API, are packed as a package, then it will be stored in the container registry, and then that will be deployed to the container environment or the Docker environment. So for that purpose, there are different services out there. So one such service is called Amazon Elastic Containers. So let's look into that. Amazon Elastic. Let's type Elastic Containers. So this one, Elastic container. So from the description itself, we will be able to understand what this particular service is for. So you can go through this description, and even before the description, from that subline itself, we will be able to understand, like EC2 container. Container service. So this is a kind of highly secure, reliable and scalable way to run containers. So there are a lot of different features out there, like if we are deploying the container inside a kind of a cluster, so if one cluster fails, what going to happen? So that all will be managed by this container service. Then the container registry, so that is equivalent to the place where we packaging and storing these particular images. So that is called the Amazon this Elastic Container Registry. So it's a fully managed Docker container registry, and it will allow you to share and deploy container software, publish. So you'll be publishing, the step is like this. Your application will be initially developed, and then that will be built and packaged into a Docker package, and then that will be stored inside the container registry. So the way by which you will be building that to a Docker package is like you will be adding a Docker file. So the Docker file contains the different information, like how much what base image it should take, what kind of dependencies that particular application will have, and all those will be all those libraries will be defined inside that particular Docker file, and based on that build step will package that and store inside a Docker container registry. So once that is there, then it will be easy to deploy that to whatever target. Like a target means this, in this case, the Elastic Container Service, and that way it can help to deploy the application. And the another advantage we just discussed is about the scaling up of instances. Container instances can be scaled upon whatever instances as we can, and that is another advantage that is provided by the container-based deployments. Then other than this, there is another one service also provided by the Amazon, which is called the Amazon Elastic Kubernetes Service. So the concept here is like, we as a developer, you will be managing this container service, and you will be managing the container service in such a way that whenever there is a peak load happening, you will be responsible for spinning up all those things and such kind of activities. So some form of orchestration should be there, and that orchestration is called the Kubernetes. So Kubernetes is kind of an orchestrator that is developed, that is a kind of a orchestration framework developed by Google, which is an open source framework, and then later added by different cloud vendors. So equivalent you can view in the Azure as well. Few weeks back I have covered a session on Azure Kubernetes service. So if you go to there, you can understand a more detail about all those things. So the advantage of using this kind of service like the Azure Kubernetes service is like, it is a fully managed service, which means that once you have an image, you can let the Kubernetes service know what type of instances you want, how much power you need, and all those kinds of things you can define using that YAML, and you can deploy your application, that package, to this Kubernetes service. So Kubernetes service will do a lot of things behind the scene, and that will be make it easy for use to Kubernetes on AWS without needing to install and operate your Kubernetes cluster plane. So this means that if you use the earlier instances as we discussed, like for example this container service or container registry, you will be responsible for orchestrating all the different activities. Like at the peak load, you maybe want to increase the instance up to 10 or 100, and after that you may want to reduce the instances. So you have to install the particular Kubernetes and all things by your own, and you have to manage all that by your own. So this service, this managed service called the Elastic Kubernetes service, means that everything is there, and you will just it's kind of a declarative approach where you will let the Kubernetes know that okay, let spin up a particular pods or instances as I defined here, and rest of the things will be managed by the Kubernetes service itself. And that means at that time of peak load, it will automatically increase the particular to different instances, and in case if there is some issue happening in one cluster, it will be automatically fail over to a different cluster. So all those things will be handled by that. So just zoom a bit and understand a bit, like a provision EKS cluster. So the step by which you are provisioning an EKS cluster is, first you will create an EKS Amazon EKS cluster. So that will help you to create on cluster, and it will prepare the environment for you to deploy your container images. Then you will deploy the different workloads. For example, in this example we discussed, we have two worker nodes, like the one for the front end and one for the back end. So we deploy two worker nodes to that particular cluster. Then we connect, when we write the YAML, and the YAML will be responsible for deploying the application to that particular EKS service. And then from the EKS control panel, we can define all sort of other things, like how much how much processing power not the processing power, how much ports you want, how much scalability you want, and all those things you can define there. And the entire Kubernetes will be managed for you based on your declaration. So that is the advantage it provides. And in actual real scenarios where container based applications are massively used, the organization use some type of service like this, like either the Amazon Container Service EKS or the Azure Kubernetes service, so that everything will be managed for you behind the scenes. It will make things a bit easier, but there are other provisions by which you can create these things, like like we discussed earlier, like you can create a, let's zoom out, then you can create a container service and container registry and then do the rest of things by your own, but that will create a bit of complexity. So that is what the difference of container using a managed container service versus the individual container service. I hope that clear different things. Then we have to cover one more thing called the AWS Lambda. And Lambda is a kind of service which is helpful for this serverless computing. So serverless, the idea of serverless is that in case if you want to spin up some particular thing, like for example, want to do some processing, like you are uploading some image and you want to process that image or resize that to a particular way, you can easily create a AWS Lambda which can do that particular thing for you, like like to get that particular image and do the resize for you, and it will also be capable of storing that particular output to a storage or S3 or some other database or whatever end location you want. So it means that we don't have to bother about anything about the infrastructure at all, and that all will be handled by the cloud provider. So that means you can sit with your computer, and if you have access to a browser, you can easily create a Lambda, write some code with whatever language you are comfortable with. Let's open the Lambda terminal and let's see how it works like. Lambda, AWS Lambda. Yeah. So the definition they provide is like run code without thinking about service. So you can easily spin up a service without thinking anything about the servers at all. Let's open the service. So there is a function already created. Let's create another function. So you can create a function from scratch, like start with a simple hello world, or you can create a blueprint, like some of the blueprints that will be provided automatically for you. Let's search for some C# application, anything is there. Okay, there's no C#. Let's say there's actual .NET Core application, anything is there, clear. But let's clear all these filters. Core. Okay, I think that is not available. I think let's go with this one particular symbol word, or you can also select a container image to deploy for your function, or if you have a custom code that is stored somewhere, you can create that particular Lambda application or serverless function from that particular code base as well. So different ways by which we can start. Let's start from the scratch, where we can start with a simple hello world example. So this is kind of blueprint, is kind of a sample templates that are provided by AWS. So let's start from here, like the AWS from scratch. So we have to provide a function line, Vishnu function 01. Then we have to provide the runtime, what runtime we want. So we can select for either for Node.js, or if you are comfortable with the .NET, you can select that one. So I selected this one. Then we can go to the advanced scene, and let's all leave that for the moment, and then let's create the function. it is spinning up a function behind the scene. So now the function is created. So the way by which function works is like the code is there, and let's test this particular code and see how it looks like. Let's click on test. So the function is executing, and the details is like the function returns a JSON called the hello from lambda and the status code as 20. So this means that it's a simple lambda function which is returning. Next, you can explain on what trigger this function should execute. So the function should execute based on some triggers. Now right now when I click on the test, it automatically executed, but I can also define on what trigger it should execute. So if I add the trigger configuration, I can select the different triggers like from here. For example, if I am inserting something into a DB into a particular bucket, so this is the bucket which we created earlier, and when some object is created or some file is added to that particular bucket or S3 storage, imagine in the real world scenario your application is going to save some image to that particular bucket. You want to write a function to automatically resize that image and store that output into another bucket. You can leverage this option. So similar way, there are different other triggers as well. So depending upon the requirements, you can select whatever things you want. So then another thing is like the cloud patch, which is a kind of a log service equivalent to that application inside. If something is there inside that particular logs, and based on that log entry, what should trigger, so that things you can define there. So for the sake of simplicity, we can go ahead with a simple S3 based trigger, and we can then we can add that. So now I have added the trigger. So this means that this particular function will be executed, and on the basis when something is added to this particular configured bucket. So I have selected a particular bucket like the my application bucket DBM added to function. You can add other triggers as well, but now we have enough of one trigger and that is fine. Now next we want to define what's the destination as well. So this function is now returning just a JSON, so it doesn't have much to do here, but we have to add the necessary codes inside the Azure function. So in this way, as an application developer, you are bothered only with actually what you need to do, and you have to don't worry about how this function is going to execute and the underlying infrastructure and everything. So everything will be handled for you by the cloud provider. So that is the one advantage of this Lambda. The equivalent of that in the Azure is called the Azure function as well. So next, add the destination as well. So let's click on destination, and let's see what all destinations are there. So the destination also we can choose from here, like the SNS queue or Lambda function. Destination type is there, like the SNS topic. Then let's click on here. SQS. Okay, we have to create a SQS queue though. See, these are the destination function. Either it can be a Lambda function. One function can trigger another function, or it can be either of this SQS queue, which is a kind of a queue based approach. Like you will be storing these particular details into a particular area. So you can do that as well. So once you do the processing, you will be creating an entry into this SQS queue, and from there it will be some other application, some kind of application will pick that and then do the rest of the processing. So this is kind of an asynchronous invocation. Let's click on that stream invocation. What kind of stream invocation are supported? So here this DynamoDB stream map to this function is supported. Then destination type is again similar. So the idea here is like this function, in this function, you create a trigger, input trigger, and that made this function run, and you will write code inside this function to do whatever you want to process. Suppose if it want to reduce an image to a particular thing, a particular size, you do all the necessary things inside here, this Azure function, in whatever language you are comfortable with. So whatever languages that are supported by this AWS Lambda, we can refer that as well and get an idea about this free access Lambda. I think majority of the languages are supported as we saw earlier. So if you look into here, you can read the different case studies as well, like how other companies are using this particular AWS Lambda. Let's do one thing. We can create another one function as well, and let's see what all the different types of languages that are supported by this function. Let's create another function like a function 02, and the runtime we can verify the different languages, like it supports .NET Core, it support, then Go supported, Java is supported, then Ruby, then the Node.js is supported, then the Node.js Java on a particular Linux version is also supported. Then these all things are supported here. I think in another session we can do a comparison between this and the Azure function as well. In Azure function, I don't remember what all supported, but majority of these things are also supported there when I looked into that, and the concept is also similar. But instead of there they have the provision, this Azure function has the provision to directly add the destination to some particular map area, like the blob storage or something. But here it have the provision to do the processing inside that function, and we have to write code for storing. In the case of image resize, we have to do the code for doing the resize inside here, and we want to store that in the Amazon S3 using the code, and then on the add destination we can add that details inside this particular topic, like a SNS topic, so that the next asynchronous service can pick these up and continue running from there. So it works like a chain of things, but asynchronously. So that is the idea here. So this way you can spin up the different functions. Then the functions are built according to kind of pay for what you use base. There are other requirements as other type of plans you can choose as well. Like if you want to have a dedicated function which needs to be run always, then you can have that option as well, I think. But by default it will be like a kind of a consumption plan, where how much you are using this function, that much you will be charged. So serverless is the concept which is always favoring by many of the application developer. This serverless and containers both are equally getting momentum. Like containers help you to easily deploy the application into packages, and can help to deploy into whatever environments that are supported by Docker. So it can help in the migration and other steps, provided if you want to switch off from one provider to another one. So that way container based deployment helps a lot, and it also has the additional ability by which we can easily spin up into different areas and into different instances and scale down as required. So that is also getting momentous, getting into the market. And another thing is like the containers and serverless is the one which we just discussed, like this case of Lambda, AWS Lambda, where you are just spinning up a particular function which will do the required things, and you are not bothered about the underlying things. So the serverless concept is also getting more popular. Some are favorable with the serverless concept, and others are going ahead with this container concept. Both are equally good, and both are suitable for according to the type of application development you want. So if you are having an application that always needs to be on and not based on a use based scenario, then going with a container approach and a kind of a web API or some model will be fine for you. But if it is based on a kind of a consumption model, like based on some IoT devices sending data or that. You can set up this serverless functions which can work based on that particular trigger. So you have to pay only for how much you are actually consuming that particular function, and that way you can go ahead. So you can do a comparison between these two and go ahead with the thing. And not just this one, there are other options as well, like you can host the website into an kind of an app service like a light sail or elastic beanstalk. And in some cases you may need to go ahead with that EC2 virtual machines as well, because you won't have other option like this containers or serverless, because you want a dedicated environment for you to run that particular application. So you may have to go with the EC2. So these all are we plan to cover in this session. Tomorrow there will be a session which focus on the different RDS, relational database services that are provided by Amazon. So if you look into here, there are different storage and relational database services that are provided by Amazon. We will be discussing those in details in tomorrow's session. So thank you all for watching this session. Have a nice day. If you have any queries or clarification, feel to put that through the comments so I can check it later and update you. Thank you everyone for watching this session. Have a nice day.